Validation, it is playing an important role in your API system to ensure that the data is gathered in expected types, mainly compliant to the defined constraints. And it is vital to define a clean strategy of validating beans and special input parameters to reduce complexity as your code grows gradually. And let's talk about validation with a kind of a practical implementation. So, as we know, you can validate input fields in most semantic way, where you will define the validators as a piece of code, or you can do it in most syntactic way using kind of annotated validators. And there are standard validators provided by packages like javax.validation, Hibernate validator likewise, which are ready to use. Else you can define your own annotations. Before all of that, let's check out what should be the rationale behind the validation as sort of best practices. Avoid shotgun approach. It is not a convenient idea to implement validations of beans or input parameters all around the code, and you should have a particular defined strategy to handle validation code. The reason is that if you have ad hoc validation in your code, it will be harder for another developer to understand, and even in troubleshooting it will be kind of a cumbersome task. And the other thing is that you will be ended up validating the same bean or the same parameters in multiple places of your code, and which will be kind of an utter mess, especially when the source code grows as you put more features on top of your code. Persistent layer and controller layer validation. One strategy is that you can safeguard the input parameters from controller if your API is based on MVC, because it is the entry point and data type and parameter related constraints could be validated before they enter into your code. One bad side of having only persistent layer validation is that params which are not validated will route up until the data access layer, and they could contain malicious data. And the destination of the input params is not only the persistent layer, and you may invoke external services while executing the business logic. And it is essential you validate data at data access layer, since the input params could have been manipulated while it is getting routed through the service or the business logic layer. Partial bean validation. Scenarios like in Wizard to break the input UI into multiple pages, then you can use group validation to validate different parts of the same bean based on some condition, but I'm not really a fan of doing this particular approach, since the implementation will get complicated when the things are getting added on the pages, and the code is indeed would be kind of less readable. So instead of using group validation, there are other clean approaches, like you can use a per page DTO and accumulate them on a particular temporary space like on session memory database, or maybe even a temporary table on a persistent database. Once all the data related to full bean is collected with DTOs, then you can trigger to persist it permanently on the database once it is completely validated. But I will mainly focus on the first two practices in this particular video. So this approach will be implemented on top of the example which I used to talk about exception handling, and you can find the link up in this particular video. And this design is able to leverage within a microservice based API environment. And let's talk about design goals that I wanted to achieve in this particular implementation. Reusability. As in this example, I will have shared set of annotations defined as well as separated set of annotation configurations. Further, both the annotations and their respective configurations are separated from each microservice, and they are generally available to consume by any microservice. So moreover, I will focusing on decoupling the configurations also, such as 4000 and 15, which are defined on max constraint on each annotation to central and scalable single source of truth. And let us find more information about the subsequent design objectives. Decouple configuration. The main idea behind is that the configurations which are shareable could be able to reuse within other microservices. As in this example, in a fleet management system, car max capacity or car registration number length should be constant value throughout the entire application, and once it is defined in one particular place as a kind of a single source of truth, modification of configuration will be lot more easier. However, there is a limitation in the standard validators to achieve this particular purpose, since the validation configurations are added at the compile time and you cannot alter those values at the runtime. So, to achieve this, we need to define validators with runtime retention, and let us talk more about those later in this particular video in detail. Avoid configuration duplication. In order to reuse configuration among services, they could be defined in a centrally available application.properties, where the annotation configuration will be the respective property key instead of the direct value. This design could be further extended, and let us enhance this under remote configuration. A centralized property file will lead to many issues like access, modification, especially in a concurrent environment. Hence, a configuration server is used which is more scalable. For this demo implementation, I have used a Spring config server, and the configuration files are exported from a Git repository into the configuration server, where we will be able to consume the inbuilt versioning and branching features of the Git. Diminish service interruptions. Another important requirement is to load the configuration upon it is getting updated on the Git repository. As per this implementation, the Spring config server is aware of updated changes to the configuration files, and we can refresh the microservice without restarting it using the Spring actuator. Let us talk about more details about usage of the actuator during the demo, and I will do at the end of this particular video. So, this is the high level architecture of this whole implementation, and on the configuration server you can import general properties from application.properties as well as service specific properties from service name.properties file. And all the configuration will maintain in Git behind the configuration server, and this will decouple the configuration and enable remote manipulation of the configuration. And all the annotations related to validations which shareable among microservices are independently developed as a validation library, and the same is deployed onto the repository management system. And each microservice will be able to access the annotations by defining the library dependency on the build configuration, like in Maven dependency or Gradle dependency, and the actuator will dynamically load the updated configuration into the microservice without interrupting the microservice availability. Custom validation development. So, to develop a custom validator, you will need to define an annotated interface with target which defines applicability of the annotations like method level, field level likewise, and the retention should be runtime for this, since we need to change the config at runtime, but the class retention will retain the code in class level and the source retention type will keep it only at the source code level. Constraint actually define the implementation class of this annotation, and documented enable to discover this particular annotation by Javadoc tool for documentation purposes. So, as methods we can define a default message to display when the annotation constraint failed to validate, and if you need to group different validations, then you can use groups, and in order to maintain metadata related to this particular annotation you can use payload method. And the parameters could be defined as the annotation configuration, like the length of the string, and if you are talking really about a particular string literal here. This is an example of above, and this will validate for max value of a double attribute. Note this max property which will define the max number of the characters is defined as a string instead of number, because we will be reading the max number from a property file, and this will hold the property key to import the value. Let's talk about the constraint class where the constraint logic is implemented. I will be using property resolver to read the property from the property file on the class path, and the constraint will have two main methods such as initialize and isValid. Initialize will load the configuration from property and it will throw an error if the property cannot be loaded. The isValid will verify the actual value of the field or method where you are defining this particular annotation is complying with the defined annotation configuration. So, that is the main difference between those two methods. This is the implementation of the max interface. The property resolver to read the config and initialize will load the max constraint value onto the validator, and it will validate whether the annotation config is valid or not. So, let us talk about isValid. This is the actual validation of the value, and if the value is less than configured max constraint, then the value will be rejected. The annotation can be used like this, and note that you can combine custom annotations with the standard annotations like positive. And the max property is defining the property to look up in order to get the maximum allowed number for the distance field. So, let us walk through the actual implementation related to this. So, in this example, I have validations added for registration number, chassis color, and even for tire data. So, according to the given constraint, the registration number should be less than 20. So, let us put some leading zeros, and it is saying that it should be less than 20, and the capacity should be less than 4000. So, if I give 5000 here, then it will give me the message saying value should be less than 4000, and it will mention the rejected value also in here. And if I revert those changes, so the request will be passing from controller and it will be going to the backend services, and it will be validating from the backend saying that record is already existing because I have already created it before. So, let us change a configuration while it is running and see how the actuator works. So, according to the current configuration, the car registration number length is 20. So, you can see the message, the value length should be less than 20 and more than 0. We will go ahead and update the property on the Git configurations while the services are running. So, these are the property files that located within the myfleet configs. Since the car registration number is kind of a global value which is shared between trips and car microservice, then it is located within the general application properties. Let us open the file. As you can see, it mentioned car registration number length is 20. So, let us make this number to 10, and I am saving the file. Then I need to add the Git file, then I need to commit the file changes. Changes are committed, then I need to talk to the microservice, and it should have actuator refresh endpoint, and when I call on this particular API, you can see it is refreshing the car registration number length max value in here. So, let us go and try entering incorrect value for the car registration number. I am entering set of leading zeros. So, as you can see, the error message has changed to 20 now. So, even without starting your services, you can change the configuration of your microservices. Let us go and check out the coding related to this. And I have the car controller here. As you can see, the max size is validated of the registration number, and as we talked during the presentation, the property key is given here. And as you can see on the search endpoint, I am accepting the registration number. So, the registration number I am validating, it should be having a particular max property. So, the max property is fetched from the property as we discussed during the presentation, and it will be validating the size of the registration number, and get registration number also having the same constraint. And if we go to the persist method On the persist, I am binding the input body parameters to postcard ETO. So, the postcard ETO I need to specifically define it to validate, since it is not a simple object. So, if we go into the postcard ETO, you can see size of the registration number, size of the chassis number, and there are a lot more things I have validated with the custom validations. And apart from that, not null is basically from javax.validation. So, I can combine standard validators plus the custom validators in the same field. So, there are no restrictions for that. So, all the custom validation configurations will be shared from a central repository. Let us go and check how the size annotation implementation looks like. So, the validation is a separate library. All the custom validators are separated from the code. So, the main idea is that all the microservices can share those validators. So, those are the custom validations that I have: is date, is time zone, max and size. So, if I go into the size which I have implemented in this example, it is having a default message, group, payload, and the minimum property and a maximum property. So, if I go to the implementation of size, you have size validator. In size validator, we inherit from constraint validator. So, we need to define the generic type. It is mainly referring to the size annotation, plus we are talking of char sequence, a particular set of characters. So, during the initialization, it will load max and min properties from the annotation configuration that we have defined on the annotation itself, and thereafter it will validate those annotation configuration is valid or not. And thereafter, on the is valid, the value given on the real attribute will get validated. So, it will compare the value defined on the attribute is really complying with the annotation configuration constraint that we have defined. And you can find startup details related to this project in the exception video that I have recorded before, and you can find the video link below in the description section, and all the links to the repositories are also defined there. You can try by yourself. So, I hope this video is helpful for you. So, let us meet again in another interesting video like this, and please make sure your post notifications are on. Until then, stay safe.